Hello and welcome back to AP Pre-Calculus. Today's lesson is 2.13, Exponential and Logarithmic Equations, Part 2. Previously in this class, we've looked at inverse functions and finding the inverse to a given function. And what is an inverse? It is not the opposite. It is a switching idea, right? And we've done it with exponential and logarithmic functions. So this exponential function in logarithmic form would be inverses of each other. So now we're going to look at finding inverses of exponential and logarithmic functions in the general form. So here is our general form of exponential. What does this k do in a transformation? This is a vertical shift, right? What does the h do? That would be a horizontal shift. What is the a? That would be a vertical dilation, right? So over here, we have the same things, and it's the exact same. Vertical shift, horizontal shift, vertical translation, right? So we can find the inverse of y equals f of x by determining the inverse operations to reverse the mapping. So we're going to switch the roles of x and y just like we did before. And then we're going to use the inverse operations to solve for y just like we did before. And then we're going to write the final inverse function using the correct notation, meaning f negative 1 if it is a inverse function. All right, let's give this a shot here. We want to find the inverse of this function. So we have to switch the x and the y. Remember, f of x is another way to show a y. So if this is the y, I'm going to make it x, right? And I see the x up there. I'm going to make that y. I'm going to go ahead and move a couple things at one time because we've been solving equations for so long. You should know that you should add 15 and then divide by 3. Now there's a couple of different ways that we could get the y out of there, but the easiest way is to rewrite this in log form, right? So I put log. Logs are equal to exponents. Well, which of those is an exponent? Well, the y plus 4 is an exponent. And then I put my base down there, throw parentheses, x plus 15 over 3. And now we can solve for y. I'm going to put my y on the left. It's a little OCD. I'm going to move the 4 over, making it negative. I'm going to put it first, all right? I don't have to, but you should get in the habit of doing that, and then write out the rest of it. Since I have the x plus 15 over 3 already in parentheses, it would have been okay to put minus 4 after that. But this is a good habit to get into. Just always put your constant first. All right, example 2 gives us a logarithmic equation or function, and we want to find the inverse of it. So I know that my inverse will be an exponential. So I'm going to have an x up in exponent somewhere. So let's start by switching the x and the y. Remember, g of x is the y, so it becomes the x negative 3 log y minus 4 plus 6. Don't forget to put your little base of 5 down there. I forgot that earlier. All right, so now I'm going to solve for y. I got to get all those other things that's not connected to that log over, so x minus 6 over negative 3. That's going to be a little bit of an issue. We'll fix that in a minute. Remember, you should not have a negative in the denominator of a fraction. So we'll fix that in a second. All right, so how am I going to get that y out of those parentheses? Well, I have to rewrite it in exponent form. So what is the base of this log? It's base 5. Remember, logarithms are equal to exponents, so that is the exponent. And I'm going to divide all three of those things by negative. So I got negative x plus 6 over 3. And that equals y minus 4. One last thing is to move that 4 over, and it's the constant, so I'm going to put it first. Negative x plus 6 over 3. Boom. There is the inverse to that log function. All right, example 3 gives us a function h, and it tells us what it is, and it says, hey, let k be the inverse of that function. For what value or values of x will k of x be equal to 1? So let's go ahead and figure out what that inverse function is going to be. So this becomes the x Change this to a y plus 1 minus 2. That's not a 2. That's a 2. Add the 2 equals 3 to the y plus 1. Let's go ahead and write this in log form. So I got log base 3 of x plus 2 equals the exponent of y plus 1. So y equals negative 1 plus log base 3 x plus 2. So there is the inverse function. Now we got to see, where does that equal 1? So let's put the 1 where the y is. So there's a 1 equals negative 1 plus all of this goodness, x plus 2. Add the 1. Rewrite it in exponent form. So I got 3 squared equals x plus 2. That's going to give me x equals 7. Man, that was a lot of work there. So there might be an easier way to solve this. We could do this in like the ordered pair way that we kind of did earlier in the lessons. So we have a function h of x, and we have its inverse, which is k of x. And this is saying k of x is equal to 1. Is that 1 the x value or the y value? Well, the x value would be in there, right? So this is the y value. But through the idea of inverses, we switched our x's and our y's, which means for the original function, it was the x value. And I could go back to the original function. Remember, this is the original function. 3 to the x plus 1 minus 2. And I could put 1 in for that, and I get 3 squared minus 2. Isn't that what we had right there? And we got 7, and it was a lot faster. So we could do it the mathy math way and do all of the steps. Or since we learned about this ordered pair and the switching idea, there's other ways to get to Tampa. So if you remember in an earlier lesson when we were talking about polynomials and rational functions, we had to solve those. And we had to find a whole bunch of things like zeros and wholes and vertical asymptotes. And then we used a sign chart to see where our function was greater than 0 or less than 0. We can do the same thing involving exponentials and logarithms. Let's look at example 4, okay? So in example 4, we are given a function, it's a logarithmic function, and we want to know, where's that function greater than 0? Where's it going to be positive, right? And we did this before with our sign charts. So we're going to have to make a sign chart. But we got to start out, like, we have domain issues, right? So if I look at these things, I'm going to take this guy right here and say he's got to be greater than 0, right? Which means x has got to be greater than negative 3. So in our infinite number of numbers in our domain, we actually just got rid of a lot. Everything that was negative 3 and less, we had to throw away. They're not part of our domain. All right, we'll come back to that in a second. So let's set this up. So I have log of x squared minus 4x plus 7 minus log x plus 3, and they're telling me it wants to be greater than 0, okay? So we have a couple of options here. We could condense this side down to 1 log and then rewrite it in exponent form, or this might be easier, move this guy to the right-hand side. Since that's a 0, when I move this over, it goes away, and I end up getting this. I get log x squared minus 4x plus 7 is greater than log of x plus 3. And the logs kind of go away, and I get x squared minus 4x plus 7 greater than x plus 3. Since I got x squareds and x's, we're going to move everything over to one side, and that's going to give me x squared minus 5x plus 4 greater than 0. And that's factorable. Minus 4 and minus 1 greater than 0. So we have a 4 and a 1. Okay, so let's make our chart. So here we are. Here's our line. I want to talk about this guy. We have to put him on there. So we put negative 3 right there. And then let's put our other guys on there, 1 and 4. Notice I was bad again. I had to go back and put my x equals. Okay, so here we are. Let's do our chart. All right, let's get back to our sign chart, okay? So I'm going to put a big red X over here because we can't go that direction. Why can't we go that direction? Well, all of those numbers will turn this into a negative after the log, and we cannot have that. So we don't have to worry about any of the numbers over there, but we do have to worry about numbers in between 1 and -3. Well, what's a good number between 1 and -3? Let's use 0. I like 0. So we're going to take 0. It's right there. We're going to come down here to this part right here. We're going to put a 0 there and a 0 there. That's going to give me negative times negative, and that will give me a positive. Let's pick another number between 1 and 4. I don't know. Let's try 3. So if I put 3 right here, it's going to give me a negative. It's going to give me a positive there. That's going to be negative. Let's try a number bigger than 4. Let's go to 10. I like 10. So if I put 10 here, it's positive. If I put 10 there, that's positive. And we get a positive here. So where is my function positive? Well, we got to do it in function notation. So in between 3 and 1, and it doesn't have the or equal to, so we're not going to use any brackets. And I'm going to union that with 4 to infinity. All right, so it's same question written a little bit different. I want to know when is g of x going to be less than h of x. So let's go ahead and write it out. I got natural log of x squared plus x minus 5 wants to be less than the natural log of x plus 4. All right. I don't really care about the natural logs anymore because they can go away. I'm just going to go x squared plus x minus 5 less than x plus 4. Move everything over to the left-hand side. I get x squared minus 9 because the x is canceled out. And that's going to give me x plus 3 and x minus 3. All right. Now, we didn't do the domain, so let's go over here and do the domain again real quick. Let's do that guy right there. So if I set the x plus 4 greater than 0, x has got to be greater than -4. So that's going to help me out on my sign chart. I'm going to put -4 here. What is this x? This x is -3. This x equals 3. Hey, I remember to write x equals, go me. -3 goes there. 3 goes down there somewhere. And I'm going to put a big red X right here because I can't go in that direction. It'll make negatives after the natural log. All right, so we got to pick some numbers here. In between, so I'm going to use -3.5. If I put -3.5 there, I get negative. I'll get negative there, and that's a big positive. I'm going to use 0 in between -3 and 3. If I put 0 here, it's positive. 0 here is negative. That's going to give me a negative. And then I'm going to use 10 because I love 10. So put it here. 13 is positive, 7 positive. So we get positive over here. So what does our interval look like? -4 to -3. Union that with 3 to infinity. All right, here in example 6, we have an exponential problem. And this time they want us to have the function less than or equal to -31. All right, so let's go ahead and start out by writing that out. So 1 minus 4 times 2 to the x minus 3 is less than or equal to -31. So let's go ahead and move some stuff over. I got to get that 2, the base 2 by itself. So I'm going to subtract the 1, and that's going to give me a -32 on the other side, right? And then I'm going to divide by -4. Now remember, we got to go all the way back to Algebra 1. And when you divide an inequality, when you divide both sides by negative, what happens to that symbol? We got to flip it, right? So we're going to have 2 to the x minus 3 on this side. And this worked out pretty nice. That's a nice little 8 right there. Now, I could use logarithms if I wanted to get the x minus 3 down in the real world where we can work with it. But 8 plays really nice because 8 is really 2 to the what power? Right? 2 to the third power. And then since the 2's are the same, we could just forget about them and do this kind of stuff right here. So we have x is greater than or equal to 6. Now I didn't have to worry about domain on this one because in exponential functions, our domain is all real numbers. So we have our answer right there. X has got to be greater than or equal to 6. That's a little elementary to say that. So let's put it in this notation, our interval notation. And notice I used a bracket because it's or equal to.